calculate what the test statistic will look like. So what I'm going to do over here is I'm going to have the parallel proportion. Over here, I'm going to have a comparative, which is the test statistic that we once calculated by hand for proportions. And we haven't done it since because we've gotten tired of doing them by hand. But I want to have it up here for reference when we think about the means, because they're almost the same exact formula. It's kind of like speaking in Portuguese versus speaking in Spanish. Same kind of thing with slight underlying differences. So the test statistic we determined back with proportions was you took your sample data's center and found the difference from the assumed population center. And that's where the news media stops. They give you the absolute change. That's where Emily goes, you can't do that, because it doesn't tell you what. Say that again. Oh, I did. Yes. Everything else. It's a great answer. What is it? What is the one everything else thing that it doesn't tell you? Right. So you divide by that standard error that you guys are always talking about so properly, and that tells you how many standard deviations you are away. As soon as you divide this difference by one standard error, it tells you how many standard errors you've gone away, and it gives you a measure of, what is that word you used earlier? Close, right, Veronica?
Yeah.
It gives you an idea of closeness. If you divide the absolute difference by the metric stick of standard deviation, it tells you how many standard deviations. It tells you, okay, we're close or we're far within certain levels of confidence. Let's mimic that over here with means. So instead of using Z, you guys already told me we're going to use T. Excellent. It's going to have the same shape. Absolute difference metric with a standard deviation. So what's the analog to p hat for continuous data? We already looked at it today. We already calculated it today. X bar, yes? Is p hat's the sample proportion? The sample average is X bar. And we know what that is. It was 94, yes? It was 94? I believe something like that. Yes. Good, good, good. Minus. This is the assumed population proportion. So what's going to go here? The assumed population average. What do we call that? Yes, we call that mu. Yes. And we know what those two values are right now for our data, don't we? We know that's 100, and we know that's, I think, 94, if I remember correctly. Good! And that's where I stopped and I said, it's lower, -6. And you all said, wait a damn minute. How low is low? I said, oh, what do you mean how low is low? And that's when Austin kicks in with a sample thing. Thanks, buddy. But he's 100% correct. You have to then divide that by a standard error, because you have to know how big -6 is. Is it big or is it close? I don't know. So what do we divide by? This you might forget from back in the day. What is the sample standard deviation from continuous data? What do we call it? We saw it earlier on the TI. You actually referred to it when you pointed to that to disprove me. The sample, not the population. Little, it's almost a trick question. What does the word sample start with? S. Little s, remember him? You guys are so good for saying sigma. Because that, at the end of 243, we were spending a lot of time talking about sigma because we had the whole population distribution. But now we're back to it just having a sample again. So little s, but we can't just divide by little s, can we? Why?
Because we have to take the sample.
Yes! Yes! Because of three little words that rhyme with ventral quimit-beerum. Right? That was the whole point of the central limit theorem, yes? Sorry about that. The whole point of it was what Austin said, as the sample size goes up, the standard error should go down, so we have to divide that bad boy by the square root of n. Do we have all those numbers in our calculation? Yes. Are we going to calculate it by hand? No, I don't want you to. This calculation in particular, for some reason, throws people for a loop. And that's not the only reason. That's not the only reason. Let me do it real quick for you, if it's okay with you guys. Let me real quick calculate that in the TI, because I can use the variable calls and actually throw it in the TI real quickly. You guys don't have to do this. I want to prove to you why, when you do that, you're not even done at that point. Okay? So just hang tight.